This conference will now be recorded.
Okay, good. Right. The problems of trying to do it two ways, so apologies for that slight technical hitch. So I'll hand over to Jason, and I shall get out of his way. And,
so good evening, everyone. My name is Jason Saxon. I'm the Director of Asset Information at Network Rail. So a big part of that job involves actually running our infrastructure monitoring fleet. What I'm going to talk to you about tonight, what I was asked you by INECI, was how I'm going to do a bit of an introduction really about how we're actually changing some of that stuff. So it's not just about what we do today. So I'm not going to give you the usual presentation about what we do with the railroad trains. I'm going to talk to you about what our proposal is to change that and change our approach from Brian and David. So I'll get on to that. Just to say a bit briefly about me first. I'm slightly worried by the fact that I expected to come here and not know anyone on the call, and I just had a quick look, and then do know some of the people on there. But effectively, I'm quite new to the railway, really. It all still feels that way. So despite the fact it's my lifelong aim to work on the railway, I ended up actually working in the water industry for 20 years. And then dragging my family 400 miles to come and live in Milton Keynes, although we don't quite live in Milton Keynes because that was not allowed. So I still feel quite a relative newcomer. And I guess my ask today actually is that you guys that have been around a lot longer than me, if you hear anything today, particularly from me, that you think is not right or not the right answer, please tell me. I'd really appreciate it. We're about to spend quite a lot of money changing the way we do infrastructure monitoring, and therefore it's important we get this right and we get this. I'm now very quickly going to hand over to Brian, who's going to set me off the presentation with me, just so you can quickly visual. So yeah, my name is Brian Reynolds.
Can I pause you guys very quickly? Several people are saying the sound is not fantastic. We're just quickly going to do the mic, move the mic and see what's going on.
Do we need to do a radio 1, 2, 3? Testing.
is that any better? Can you?
You're fine. Would you like to go?
Yeah. Keep going. Yeah.
Say something.
Yep. Testing.
Yeah. Crack on. I think I'm happy with that.
So I'm Brian Reynolds, trains. I'm one of the product managers at Trains, and product in my world is an entire rail all the way from the wheel rail interface up to the pantograph, and that's very
it's really quiet. So just sorry.
Maybe that's the best thing that people can't hear us.
We could put it really close.
Although that microphone issue.
It does.
Try again, gentlemen. Say something, please.
Testing. Product manager here. Angel Trains calling.
Product placement. Isn't it?
Yeah.
I think it's working, but you're still quiet. So if you can just
Project.
project.
That's my introduction probably done.
Fantastic. Okay. So, as I say, if you say anything, I think we covered questions earlier, and I think it's become quite difficult. You just put any questions you want to ask in anyway. So, opportunity right at the end. So I said I wasn't going to talk a lot about what we do today, and I generally mean that, but for anyone that's new to infrastructure monitoring and how we go about it at Network Rail, we actually collect quite a lot of data streams. They're under the data outputs bit here primarily. I've actually taken not all of these are equal in terms of the importance that they have today, at least in terms of keeping the railway performant and open. However, what this slide really tried to show is that our approach today is to actually buy quite a lot of components. And then I have a team split across Derby and Milton Keynes that actually run a fleet of trains and actually collect and process that data and quality assure it. And then finally, that gets put into in a form that our route users can use, so that we can avoid sending people out on track to find the problems. So, and there's quite a lot of history to this, so I'm not going to go into that today. If you really want me to come back and tell you about the history, I went and learned quite a lot about that, all the way back to British Railways research, because I wanted to know. Particularly as I used to travel past the Railway Technical Centre in Derby as a child, it used to fascinate me, with stuff that I saw on my way from Birmingham to Nottingham. But I'm not going to talk about that today. This is really the approach, really. So the trains that we run, we've only ever got, well, I think we've only ever bought one dedicated measurement train, which is actually the Class 950 Sprinter. That was the only one that's ever been purchased recently. It is a dedicated measurement train. The rest of them were primarily Mark 1 and Mark 2 coaching stock. We have got one HST, and that's pretty much what I was going to say. And pretty much all of the information we collect about infrastructure today, and we give to the route customers in Network Rail, we collect using that dedicated fleet. There are a few exceptions which are very recent. So we have overhead line equipment on the West Coast Main Line from a Pendolino, which is operated by Angel Trains. Well, it's not operated, but owned by Angel Trains. And we also have a Class 360 on the Midland Main Line that collects overhead wire information, but both of those are very, very recent. If you think most of this has been growing for sort of 20, 30 years plus, some of our dependence on service trains is actually very, very recent. So that is all I was going to say about that. In terms of why do we need to change? So I said I was going to talk to you about the approach primarily, and that is that there's still quite a lot of data that we collect manually at the moment, so that's quite a big thing for us. So we work predominantly in track, although we do some Eveleigh, Conrail, other stuff, but we still send quite a lot of maintenance and engineering teams out on track to do inspections, so there's quite a lot to go at, particularly on things like S&C units. We also collect a lot of data, and for a lot of the time that we've been collecting this data, we haven't always been able to turn it into insight. And some of the most recent changes in data science and artificial intelligence mean that we can actually analyse data in real time using a whole bunch of technology that we've not had for most of the time we've had instrumentation. But the biggest one, if you spoke to our route customers, and I'm now got some of them on actually watching this, is the reliability. So for a lot of the time we've had the dedicated fleet, we've had the flexibility to collect data manually as well. But on some of the data streams we have now, we don't have that flexibility. So things like reduction in red zone working mean that actually the trains need to be a lot more reliable now. The dependence on them is now so much higher. So even when I started in Network Rail, and I wasn't responsible for these services 7 years ago, SLAs of about 90% were okay. We're now achieving something like 97, 98. That's still not okay. That leaves enough miles being missed that we cause our route customers quite a lot of problems with even that minor level. So we need to uplift that. So that is probably of all of the reasons, that's one of the primary ones why we need to change. We have set some challenging goals. Andrew Haynes is personally interested in this, which is good and bad. Like I said, I don't think he's on the call, so I might go away with it. So effectively, we do actually intend to reduce costs. So we're not necessarily saying we're going to reduce the cost of infrastructure inspection, but overall, the way we actually use that data to provide a performant railway, we think we can reduce the cost of that. We can certainly speed up the amount of hours from measurement to insight. Sometimes that takes quite a long time. And I've already talked about service levels. And we also think we can remove 1 million hours of boots on ballast, and that's really, really important to us. So as some of you know, we've got some fairly terrible events in recent history where people have been out on track doing inspections and have sadly been killed. And again, that is just one too many every time it happens. And therefore we really need to step up our efforts to not require them being on track when we've got an alternative. And then we've got the reduction in emissions. So again, there are certain commitments that have been made slightly different between Scotland and England at the moment. But it would be wrong not to mention that. And then we think there's a massive opportunity with unattended systems, which again we're talking about tonight. In terms of what it looks like, I'll not go too much into this. Is not my slide, actually, I've got to be honest, but it does match the Network Rail hearts and stuff like that, which I feel contracted to share. But effectively, what I really want to get at here, we've talked about insight, not data. Our route customers are very time poor, and therefore need a better service from me that provides the insights. They don't want me giving them loads of data. They want me telling them, this is where you need to go and look at the infrastructure. This is what we think is wrong with it. And therefore, please get that to them in the most time efficient way. We also have built the IM fleet up. This is quite a minor point for many, but for us it's quite important. In a sort of a one size fits all. So for most of the time Network Rail's been in existence with IM, we've tended to treat the whole country as equal, so track categories, drive frequencies and stuff like that. But with devolution, we actually are seeing some quite different, some significant differences now, because there are different challenges and they're clearer now than they were before. And we spent a lot more effort speaking to our customers of late to make sure we understand the difference between Anglia and, for example, Western and Wales and Scotland, which are very different challenges in many cases. And again, we've learnt a few lessons along the way as well. So we've not actually, sometimes when we've done some things on service trains, we've tended to be under the wrong impression that service trains have to do exactly what the IM fleet does. They don't. They can do something quite different. It's how you combine them together to get the outcome that is important. So again, we're changing our approach on that. And we're also not trying to give ourselves a hard time about being, when we do experiments, getting them absolutely perfect. So again, I think we've driven some of our route customers mad sometimes by doing experiments and working with our technical authority, particularly on absolutely the most nth piece of detail, and rather than just getting them the outcome that we need. So we're trying to move that forward. In terms of how we set so we've created an infrastructure monitoring program. I'm the client for that. It's a fairly expensive program in terms of, it's not if you compare it against the Great Western Electrification, but it is still pretty big in terms of the investment we're making in this particular subject area. And what we've tried to do, because there's quite a bit of sensitivity in Network Rail on big national programs, is we've tried to mix getting more out of what we do today for our customers, but also looking at what it will look at for beyond 2022. And trying to not keep them separate as such, but not just say to the customers, we're going to ask you what you want, and in 3 years' time we'll have a big ta-da moment, because that really wouldn't be very welcomed. That there are certain things that are needed now, and therefore we set it like that. In terms of what's on those paths, those different paths, so today we've accelerated some data delivery, so forward-facing video. When I first started in Network Rail, we were distributing forward-facing video on hard drives. It's actually genuinely quite embarrassing, but it was effective, and it's taken us until relatively recently to make that on demand. So we can now take forward-facing video, and within a couple of hours, actually have that available on a portal using a product that we purchase. And again, although to us that was relatively simple, to some of our route customers that's quite a game changer because they've never had that, and it was quite a convoluted process. There's class a class 360 there, so again we've tended to fixate on track, and track is always going to be important to us. I'm sure some in this audience would like to know, but on things like OLE, we've not probably put the effort in that we should have done. And again, we tend to collect data and use it once. We tend not to combine it to work out what it will tell us. So again, we're trying to use some of those new technologies. S&C inspection, we've got a trial at the moment using class 153, where we've actually just rented it, and we've put some equipment on it so that we can see if we can do more in the S&C inspection space to remove some guys from ballast, and also ultrasonic rail floor detection, which again a very important topic. We're trying to get more out of the capability that we've got. I think in terms of the long term, and this is where we're working with, particularly with Angel Trades, although some of the short term stuff we're also doing with Angel and other people. We know we can do a lot more with service trains, and again, because we can combine service train information with the dedicated fleet, we're coming at it in a very different way. So we're not trying to replace necessarily what the dedicated fleet does, but for example, it would be a massive benefit if you could use track geometry off service trains to push out the frequency of the dedicated fleet. that would open up a whole bunch of benefits that we've never really explored, because we've been fairly clear that, well, we've given the impression it has to be one or the other. We've not properly considered the combination. Working with TOCs, again, on service affecting failure reductions, again, doesn't have to be the same equipment I've got on our trains. But it can still be stuff that really delivers quite an important benefit for a relatively limited cost, and the guys will talk to you about some of the stuff they've done there. But also, because Network Rail is so huge, sometimes there are experiments going on in IM that one customer's doing in, say, northeast of England that no one else really knows about. So we spent quite a lot of effort in the last year to make sure that all of the various innovation that's going on is actually known to as many people as possible. So we've run various events. And the nicest thing about those events is the sort of people that have turned up. So they've not been people like me with management positions and director in their job title. There's been TMEs, RMEs, people that are really at the front end. And that's been a massive focus for us, actually, because the people who are my real customers are the people that use that data to keep the railway safe. And again, we've come up with a rule that says if there's not an outcome that makes someone's job at the front end an easier thing to do, we're just not going to do it. That is genuinely what we're going to do. And in terms of how Network Rail goes about it, we tended to prescribe everything. So this is a phrase that doesn't be very popular sometimes in Network Rail, but my observation is that when we write standards, we not only tell people what we want, but we tell them how to do it. And then we get really upset when we go to the marketplace and we say, you're not very innovative, are you? And that's because it's my observation, we don't give people enough time to remove and innovate. So what we've basically said is on IM, we will tell the market what data we need. We will not dictate how it is collected. We will not dictate the technology. There are certain things we've got to do around product acceptance, but we don't have to do what we do today, which is dictate so much of how it's done. And that's a really quite big change. So when we do come to the marketplace, what you will see from now on is we will say we need this data for this section of track at this frequency and at this reliability, and we're going to ask the marketplace to tell us what it can do. And the advantage to us is we give people greater room to innovate, but also we can pay for an outcome, pay for an output, which today we can't do, and we don't do in very many cases. So that's pretty much quite a lot of change there. I'm not going to pick up too much of this because I've sort of covered it and I'm conscious of time. One of the things that we will do as well is all of the infrastructure data that we collect in the future, we're going to make that available in an open access portal as much as is humanly possible. So particularly because of the innovations in data science, and there's very little of the IM data that has got a security issue around it, even though we worry about that incessantly. We're going to make as much of that data available to people with metadata so that they can innovate. So we're seeking over the next couple of years to create an open access data place where anyone that's interested can go and look at this. And in combination with a bit of detail of the problem we're trying to solve, we're hoping that will encourage people to work with us, because we sort of do realise within Network Rail we're not always the easiest to work with. So we're quite keen to change that. And this is what I'm going to hand over to Brian.
Thank you, Jason. Right. So my name is Brian Reynolds, again, another introduction, and an introduction of Angel Trains. What I'm going to talk about is how we're trying to turn what Jason and the Network Rail team want to try and achieve into a case study, essentially. So we'll talk about the Class 360s on EMR and how we're all working together with collaborative manners to lead cross-industry collaboration. So I'm just going to put all of these up because there's far too much animation on all these slides. But essentially, Angel Trains needs no introduction in general on the rail industry. There's a few critical bullet points up there, but essentially at our heart, we are asset managers. That's what we do. We own over 4,000 passenger rolling stock vehicles, and we know them inside out. And what we want to do is use our asset management skills and experience to assist not only us as rail vehicle asset managers, but try and assist Network Rail with their asset management as well. And this isn't something that's just sort of a light bulb moment recently. This is something that we've been thinking about for a long time. And maybe the access has changed where we were assisting the TOG as our customer. But what we want to do is broaden that now to make the whole railway our customer. And the key bullet point on this slide is rail people, real expertise. That is what we are, Angel Trains. So we'll take a case study. We want to utilise our rail industry relationships and engineering expertise. As I said, we are we're passionate about an optimised whole rail system, and the movements that are coming towards Great British Railways.
Sounds just stopped working. I'm sorry, with apology there. Not sure what it's.
Are the pictures still not?
I'm going to have to mind this. Through the meeting with it. Through the meeting with the dance. No, it's worse than singing.
Right, say something again.
Solid state reboot, that work?
Nothing coming out?
Yeah, that works. Came through there. Yeah.
I'm back on.
It must be the connection on the phone, I'm afraid.
Is it fine?
Can you hear that, Paul?
Yeah.
Okay,
Okay.
we'll keep going. Sorry about that if anyone missed anything online. I think all the people in the room heard it. It was brilliant. So I don't know if Philip's keeping up with the bullet points, but certainly our product team, I've been talking about the fact that we've been passionate about this for a number of years. This isn't just a recent sort of change of direction. This is something that we've been doing at Angel Trains for a long time. The product management team was set up just over 5 years ago. And we've been developing infrastructure monitoring solutions for many years, and this is about broadening our customer base, basically making Great British Railways the customer going forward. But obviously, initially, it's Network Rail acting on their behalf. And not only do we develop things in-house, but we bring sub-suppliers on board as well. So we're a one-stop shop, essentially bringing everyone together to deliver one solution fitted to our assets that will manage our assets, but also manage Network Rail's assets. So the last bullet point on there was the fact that we relished the challenge that we set by Network Rail just over a year ago, and that was, what can we, from the 18 traditional data streams that Network Rail currently gather, what can we do from passenger trains in service, and therefore saving the yellow trains having to have dedicated paths. So I won't go through every one of those 18 bullet points. That be it's a general feeling of the colour. Quite a lot of it we'd already been doing. Green means it was already passenger trains fitted. Amber means we trialled it, or we had temporary fitments that we could put on and take off. And the red bits, they're generally constrained by the passenger train being too fast for the measurement that's required on those red elements. I'm not saying that they won't be done in the future, but that was our initial first thought. So let's take the Class 360s, as I mentioned at the start, and two possible ways to look at Eveleigh, because Jason mentioned at the start, we're thinking about not only the track, but let's take the example of the Eveleigh. So the traditional method would be to measure the infrastructure, measure the Eveleigh to the nth degree, as Jason said, with a particular standard, how many millimetres, the stagger, what vertical uplift you want. And that's what's happening with a Centec instrumented pantograph that's been supported by Network Rail and Angel, but pushed forward by Eveleigh, Breckner Willis. And that's been fitted to one of our Class 360s. It's a collaboration with Eveleigh and Breckner Willis that have been working with City University. There's been Innovate UK funding in there in the past. And to get that on the train and operating, there's quite a lot of people that have to be involved. East Midlands Railways is the operator, DGA is a design house, S&C Labman project managing it, and Siemens obviously is the train OEM and maintainer. And that is going to be gathering a vast amount of data. It's quite complex to manage in operation, but it is measuring to the accuracy that Network Rail require. So the other thing to mention is it's a one-off unit. It's one Panther rail fitted to one unit. So we've got to keep that operational and in service. So that's quite a challenge. So is there another way, as Jason says, challenging and innovating, is there another way to do that? So what we want to do is help Network Rail to examine that. So that's where the Pandas system comes from. And we've got one fitted to a Class 360 unit. And the idea is that we're going to be fitting the whole fleet. So we've been working with another sub-supplier from outside of the rail industry. They're more and more in the rail industry, Transmission Dynamics. And what we want to do is monitor the pantograph and the overhead line on every single unit that operates day in, day out on every passenger service. And the difference there is the monitor word. It's not measurement, it's monitoring. That was what we set out. So looking to monitor the change of state, and it's got an accelerometer on the pantograph head. And essentially what we're doing is highlighting, as Jason said, they don't want lots and lots of data, they want actionable information to stop boots on ballast, reduce that boots on ballast time. So the idea of this is that it's actionable information emailed in real time for an acceleration over a certain threshold. We've also got video on there as well, so there's 10 seconds of video that is centered along the high acceleration with a GPS location. So you've got 5 seconds before, 5 seconds after, and you can see exactly what happened in the lead up and the following of that high acceleration. There's onboard processing, so that incorporates Network Rail structure data, and GPS location is useful in one context, but Network Rail, to save having to go searching up and down stanchions, you want to know exactly which stanchion it was at, so that we're not wasting time walking up and down and putting people in danger on the ballast. And a recent innovation, the quality of the camera, lens cleaning and LED illumination on the latest version of Transmission Dynamics Pandas system has helped with that as well. But we are engineers and we've pushed the boundaries of what we set out to try and do. Originally, it was useful information, but we've realised that there's a lot more you can do with it because we've got that information, can push further. We can, with AI and visual algorithms, we can work out pantograph height. We can look for arcing locations automatically without someone having to physically look through every single frame of a journey from St Pancras to Corbett. There's microphone on there to do audio analytics. We can work out stagger, we can work out contact force, and another thing that's always sort of bothered people with overhead lines, if you get ADD activation, why did it happen? So that's what no fault found reduction we can also get. So we're helping the operator and the whole rail system to operate more seamlessly. And then going further, artificial intelligence to try and look at things like track quality as well. Ironically, from something that we're looking at the overhead line, we can intimate track quality. We can also look at carbon chips to help maintenance of our asset, not only with Network Rail's asset, but keeping our asset in good condition as well, and carbon aware too. So those are two examples on Class 360. Just a very quick conclusion summary slide, because I'm sure we're desperate to get questions. It's cross-industry collaboration. That's what we want to do. We want to lead that, get everyone together, and we feel that as a Roscoe, Angel Trains can be the one-stop shop to help Network Rail do that and bring everyone together with our existing relationships with train manufacturers, with sub-suppliers, bringing new people into the industry, the maintainers, the train OEM builders. We've got all those relationships already in place. We want to use practical trials and data to support Network Rail's challenge, the infrastructure monitoring category strategy challenge, and definitely get the boots off ballast. And we're going to try and help Network Rail to challenge its own technical standards. And that's part of what the 360 trial is about, to compare and contrast what is the best way to do it. And then the final summary, because this was just one case study, we've got a lot of future collaborations and collaborations that are on their way at the moment. I can't talk about here in the public domain, but we're bringing together expertise from outside of the the rail industry. We want to test and prove experimentally with our assets, obviously in a safe way, but we want to move things forwards innovatively. That's it from me.
Okay, so there are a few questions arising from this bit so far. So before David starts on his bit, if we can do these questions, do you want to ask whoever's raised the questions to put their question forward?
Okay. Phil Shepherd asks the first one. He's typed it out. I'll read it out. Phil, if you want to augment, feel free to unmute yourself. If not, I'll just read out the question. Phil Shepherd has said, if time permits, please tell us more about the ultrasonic equipment that you mentioned.
Okay, so in a very short version of it, so we tend to use ultrasonic technology to look for internal rail flaws. So things like cast-in faults in the rail, particularly certain age of rail, and this is where you will realise I'm not an engineer by the way, I'm certainly not a track engineer. So that's what we tend to use it for, so that we can see inside the rail. As Brian alluded to, there's a few challenges with that. In terms of putting it on service trains, I wish this wasn't true, but that ultrasonic technology is the only way of doing that at the moment. It's the only scientific technique that exists at this moment in time to do what we do. And because it's using sound effectively, it has some limitations, and it also needs an awful lot of water to operate between the sensors and the railhead. But yeah, a very short answer, and I'm happy to elaborate on it more, albeit there are people in Network Rail that know oodles more about it more than me. If you want to go into technical detail, that's what it's for.
Happy with that answer, Phil Shepherd?
Can you tell me who makes the equipment that you use?
Yeah, it's a company called Sperry Technologies. They're a US company.
Okay.
You probably come across them by the sounds of it.
Yeah, okay, thanks for that. That's helpful.
Okay, next question comes from Ben Woods. He says, I don't think I saw rail adhesion on the top 18. If it was, apologies. If it wasn't, why not? I'm going to go back to your list. There we go. There's your top 18 redisplayed on the screen if you want to check. Oh, right. Okay. Yeah, you're on a different computer, so you can go backwards on a separate machine.
Absolutely.
People online can see it. There you go, past it.
So yeah, so the short answer is we don't measure rail adhesion at the moment as part of IM, and that really, and again, I probably need to understand a little bit more about the question.
It's quite difficult.
I've certainly, in the 7 years I've been doing this, I've never come across yet. I mean, it's never been presented as a problem, if I'm honest, but I've never, in the analysis we've done about what other railways do, it's not come through as a possibility either. Now, that doesn't, the problem with the railway sector is that despite the fact that if you know the right people, you can find out anything I've discovered, that doesn't mean that I've spoken to every person that's ever done everything and that in the world. But yeah, we've never been asked to do it specifically as from a service provider perspective. I'm not aware of the instrumentation that does it. That does not mean it's not possible.
There's a lot of existing research streams into it.
Okay.
The RSSP and funding. Guess it's something to look out for in the next few years.
And I'll try not to give too many secrets away, but it's, again, from our side of things, with considering a monitoring possibility, not a measuring possibility, with data that we have from our trainers that can help Network Rail, and it's something we have talked to your team about in general, but it's not developed as yet.
Okay, does that answer your question, Ben?
Hi, yeah, well, Ben Woods here. So I asked the question because it is, of course, something that Network Rail maintains through vegetation management and other measures, applying track gels and rail spraying and whatnot. So I think it's an area that at the moment is being maintained but not measured. And of course, if you don't measure, it's difficult to manage. And as Brian says, I think there is opportunity to take data, such as somebody else said, I think it was Neil, said about WSP activity on the train. I think it is a great area where the industry can come together. And now the technology is available, we can get that data off train. I think it could really help target management of vegetation management and railhead adhesion management.
Yeah, I mean, it sounds like a really good, and there's a certain irony at this time of year actually as well. So some of my trains are some of the least well advanced braking systems on the network because they're so old. So they get wheel flats and they cause major problems actually. So from a purely selfish perspective, that's really good to know.
Well, yeah, it's a symbiotic relationship, of course. So I sorry, I'll widen that question of the 18 then. Of the are those 18 what you measure now, or what you're asked to be done, or are they, and have you looked at the bow tie risk assessments of what are all the things we need to manage and how can we measure them?
So to answer the question in a straight way, that list that Brian put up is the list we covered that covers what we do today with the dedicated measurement fleet. We have just spent the last sort of 7 months asking the routes and the technical authority of Network Rail, this is what we do today, so let's have a discussion about that. But let's also have a discussion about what we don't do today that we could. So there are some additional opportunities on the list now, but they're not on that list. We can share that though. I mean, Brian's probably a bit more limited than me what he can share, yeah. But yeah, we could share some of the wider opportunity stuff if you wanted us to.
That'd be great, and also I'd be very interested in talking to you about getting WSP activity from the train and providing you with that. We've got some thoughts in first group on that.
Okay.
I'm going to jump to a comment that's just popped up from Phil Harper Smith. He says a comment rather than a question. Adhesion and its management will become ever more important as we move towards automatic train operation over ETCS. Links into what you were just saying there.
Good point, Stan.
Any further on that, or shall I move on?
It's a fair statement.
Yeah. Okay, so similar from Simon Wadsworth, tied in with the rail adhesion, how is trackside vegetation measured? You touched on it in what you're saying, but if you can expand on it.
I can talk about what we do in Network Rail if you would, and Brian can add in. So the experiments we've done of late have been using LiDAR and various forms of imagery, so primarily forward-facing LiDAR, look at tree canopies and stuff like that, and then work out how that affects things like signal sighting in a more automated way. We also invest once a control period in downward-facing aerial imagery, which is auto-rectified, and again that allows you to do certain things around overhead wires and stuff like that. We have recently looked into can we collect that data far more frequently, because once a control period is exactly frequent, isn't it, to be honest. It's phenomenally expensive to do this sort of stuff though, so both forward-facing LiDAR at the moment and aerially obtained imagery at the quality we obtain it. We've not been able to get the business case to work for that yet. That the cost of collection is just so high, and the business cases are just not robust enough to justify that at the moment. We think it will change in the next couple of years. We think the technology will reduce in cost, and therefore some of the barriers will get a bit lower. But yeah, it's a bit of a disappointment for me. I know we can't make that work, because that would make a significant difference sending people out for what I call go look see type events. And again, if we could do that, it would make a big difference, but it is very expensive at the moment.
Yeah, and I was going to say that certainly from passenger trains, it's something that we're looking to help Network Rail with. Already mentioned forward-facing CCTV, as one method, and there are some other methods I can't say too much about in the public domain, but we are using passenger service trains to deliver that information to support Network Rail.
Okay, question from the room next.
Raspberry for track the engineer. So I know this project you are doing very good. So we as a designer we don't go on site as usual. But I have worked in the transparent route update program, and in some respect I used that front-facing camera in the train just to see on the side and stuff. But to be honest, the quality of that camera is not very and there are no full HD, so you can't really see what is on the side, what is going on. So is there any future plan to update the cameras as a full HD or more advanced system, or which are available?
Yeah, so the cameras we've put on, okay, again, I can speak about what we've done. It might be slightly different for Angels, to be fair, but so the cameras we've been putting on lately are 4K cameras. They tend to operate in 1080p at the moment, and that's mainly because to get the data off quickly for the majority of users, you only need it at 1080p. The moment you start going, I mean, there's no reason why you couldn't take it to 4K or 8K. Some of the new cameras are 8K. The problem is the data volumes become so big, sending that across a 4G network is quite challenging if you then want to make it available quickly. So you've got this sort of like decision to make at the moment as to whether or not do you take the highest possible denominator and accept the data takes longer and costs more to get where you need it to go, or do you effectively just take the majority? And certainly at the moment we're at the moment, in terms of making it available, we do it very quick. We use 1080p because that's but the cameras certainly have that ability, and we've had some customers that have said, well, can you not do certain runs in 4K, and we'll go to a more mechanical way of getting it off the train. That is entirely possible. I'm sure Ryan's got
Yeah, I was going to say that Network Rail have been leading the way with this, with collating it, and the One Big Circle AIVR product that's been put in place is brilliant. So we're essentially looking to support Network Rail by feeding the forward-facing cameras into the information into that. And Innovate UK is sort of pushing on with some technology to use the information in a better way as well. So we've got an 8K camera going onto a Pendolino that might even be fitted at the moment, funded by Innovate UK and supported by us and a couple of others. So yeah, it's getting that information into one receptacle where everyone can go and use it. And Network Rail's doing a great job with that.
Just on the collaboration point, there are several streams of work at the RSSB going on at the moment that are looking into combining CCTV data with aerial LiDAR data, with scientific analysis data of leaf layers and the varying chemistries of different leaf types from different species of trees, to create that unified forecast. There are a number of stakeholders involved in this. I'm involved from Chiltern Railways, there's other people involved from Network Rail, Roscoe's. And hopefully in the next couple of years, especially now that we've had that unfortunate event at Salisbury, which is sad, but it will accelerate some of this work. And hopefully in the next couple of years, we'll innovate very quickly and create that model that will benefit us all.
Yeah. I mean, certainly one of the things we're trying to do with R&D is, as we invest in this sort of future model, if there is data that we need to collect that's like an add-on to what we do, we're quite keen to know about it. So even if you don't need it tomorrow, we can collect it in the future, because the most difficult thing is running the train, attaching things to it. The second biggest thing is getting the data off it if it's a bit big, as we've talked about. But yeah, if anyone's got awareness of it, we think we know about some of the R&D stuff through our own R&D team in Network Rail, but that doesn't mean we know about everything.
Okay, next question. I'm going to go back to online questions. So the next one's from Neil Halliday. Has any consideration been given to downloading WSP activity on passenger trains as a means of identifying low adhesion locations? Also, are there any plans to introduce the ability to measure actual wheel rail adhesion levels? British Rail had the Trib train with an instrumented wheel set to measure adhesion profiles.
I could take the first one if you want. Hello, Neil. Long time no speak. Yes. Yeah, definitely, and that's what I was sort of intimating earlier. Taking OTMR live stream information of WSP activity, hotspotting that on a map and feeding that to Network Rail to target the rail treatment trains, standby applications, and other bits and pieces. So that's what we're working to do. It's getting that collaboration of getting everyone together to make that information in one place. That's the key bit now. And we've got more and more remote OTMR download trains in our fleet, so that'll certainly help that.
Yeah.
And as for the second question, I'll leave that to you, Jason.
Can you remind me what the second part of that question was? Actually, I was too busy listening to that, to be fair. But
are there any plans to introduce the ability to measure actual wheel rail adhesion levels? British Rail had a Trib train.
So I know about the Trib train. That goes back some distance, to be fair. So this is not my area of expertise, but I am aware there are some R&D stuff, and actually some of you guys might know more about this than I do. So I'm not gonna, I can take it and go away and find out, but I'm not going to pretend I've got all of the information to answer that one. But I've got a vague memory. I've read some scopes on R&D projects that have that in it, but my memory's not good enough at my age to remember all that now.
Fair enough. Okay. So next question comes from Simon Wadsworth. What plans are there to monitor OLE in tunnels, or is maintenance less problematic with conductor rail systems?
So I mean, we haven't differentiated actually between, so certainly in the conversations we've had with routes, I mean, clearly there are conductor beams now in some of the more recent stuff. And I've got to be honest, we tend to use them as specimen locations now to testing, so they move about a lot, which is really helpful. But yeah, we've not differentiated. I mean, also there are different problems associated with that sort of stuff. But yeah, we've all of the systems we've come up with so far around OLE measurement don't really care whether it's a wire or a bar, is my understanding.
And from our side, the fitment of lights to make sure that the imagery in tunnels works.
Yeah. I mean, certainly all the service trains I've seen that we've put OLE on have got lights on them there nowadays, so for that very reason. So,
cool. As I'm moving on, all these people that are having their questions answered, if you want follow-ups or anything, feel free to unmute yourself and respond to the commentators by all means. I've also only got 3 more questions. One was popped up. So if anyone else has any further questions after that, chuck them in the chat or let me know that you want to unmute yourself. So moving on to the next one comes from Phil Harper-Smith.
Missed one there.
Oh, sorry, I missed one, haven't I?
Yeah.
So, apologies. Comes from, I'm guaranteed to pronounce this wrong, Yesh Saw. Apologies if I've said your name incorrectly. Is there an opportunity for the track to scan trains to scan the track, and then merge the two?
goodness me, that's a.
Shall I elaborate on that?
Yeah, it might help my brain, but.
So if you got whatever sensors on the train and it's going up and down the same track, it kind of learns what's normal and what's maybe unusual. And then if you have similar sensors in the track that can kind of recognize what a regular train looks like, it may be able to differentiate between a heavier train, a different class of train. But if you were to synchronize the data in terms of location and time, and with a bit of AI over a number of months, you could recognize something's not right. And when you start building up data on saying how something should be, you could detect maybe axle bearing faults, abnormal track wear, etc. Just the opportunity to join two things together, and then the whole becomes greater than the sum of the parts. I'm just wondering, are you thinking that way?
Do you want to go first, Brian?
Yeah, well, on the track measuring the train, there are certainly lots of sensors out there at the moment already. I mean, from the basics of high axle box detectors from years and years ago, up to I'm trying to think of some others. Well, there were UGMS bits of kit, weren't there, at Banbury, monitoring the trains as they go over the track. But certainly the integrating the two, it's not a conversation we've had right yet, but yeah, it's certainly something that we could look at.
I mean, one of the things that AIS does, Asset Information Services does, is we also look after the wheel impact sensors that we have on the network, so they tend to be very strategically placed. And again, we look after that data and match that to train so that we can warn sort of the owners and also the relevant maintenance staff what's going on. But yeah, we definitely haven't thought about taking the feeds from on-track sensors and trying to match them with the trains. I need to have a think about that, I think.
Yeah, I mean we've tended to shy away a little bit from stuff that's bolted to the track for guaranteeing the health and safety of our trains, because it is, as Jason says, it's in a key location and it's just one location, and each of our trains has to go over that location to get the information to us. So we've tended to go for on-train sensors that are monitoring our train all the time, wherever it is, because think about the complexity of the West Coast. we've got to make sure that the pendolinos run over a particular set of track if it's bolted to the track. And it might be doing a Birmingham service and never go up to Glasgow. So therefore we miss that opportunity. Yeah, but no, that's an interesting one for augmenting the two.
Thank you.
Okay. Right, next question comes from Simon Wadsworth again. Railhead treatment trains use a lot of water, so could measure adhesion before treatment, ultrasonically test after cleaning, but would need more railhead treatment trains if slower. Simon, I don't know if you want to unmute and elaborate on that.
Not, I guess he doesn't, or he didn't hear you. It's a good suggestion, though. It's something that we could certainly think of.
Yeah, I mean, certainly for the period of a year that they operate, obviously that would work. Again, we have looked up. I mean, we do have some track geometry. Just as a similar example, we do have track geometry information on tampers, for example, that collect that sort of data. And we, but because it's very tied to very specific locations. We don't use it. We use it to supplement, not replace at the moment. So, okay.
Next one is again from Simon Wadsworth. How deep can you get a GPS signal?
How deep?
Yeah. Interesting question. Deep.
So if it's in relation to getting a location, we're probably going to move away from GPS actually in the not too distant future. In reality, so. Partly because GPS has its own problems. So certainly things where you get problems with.
So you just stop transmitting. So
okay.
Come back. It's just a glitch.
Okay. So we're actually using different technologies now to try and get locations of track faults or anything else. It doesn't really matter. In my case, it's track faults or Eveleigh faults. And there's a piece of technology called raillock. Which actually comes from the automotive sector, so it comes from autonomous vehicles. And what it does is it uses an image of the railway and it matches that using AI to a very accurate location. And then every time you get a fault from that point onwards, it just knows exactly where it is. The algorithms are phenomenally intelligent. But the most important thing about it is it gets you down to plus or minus 40 millimeters. So that train knows where it is within 40 millimeters, which is way higher than most things ever need. And that really, whereas GPS, as we fit it today, even when we correct it, is probably plus or minus 5 meters. So it's not as good. They are just magnitudes apart. And of course, we also on the railway have lots of station canopies and all sorts of stuff that mess up GPS. So our plan at the moment, we're trialing it. Well, we've trialed it on one of our measurement trains, and we're now going to start. We've actually put it on the 153 that will do S&C inspection, which again tends to be in station locations at the moment on the trial, and that's our intention, is to use solutions like that rather than GPS.
Okay.
Hello, it's Simon here. Thanks for the answers. Apologies for not replying before. I was trying to work out how to unmute myself and get myself on the right microphone. No, it's just with the railhead treatment trains. Their trains are under control of Network Rail, and you're saying that the problem is getting trains available to do things. It just seemed that combining something that already uses a lot of water and actually could prepare the track in advance of ultrasonic inspection.
No.
Would be worth considering. That's all.
Yeah, no, I wasn't. I'm not arguing that point at all. To be honest, it's not something we've considered. And my only immediate issue, obviously they only operate at certain times of the year, which is blatantly obvious. But yeah, there's nothing wrong with it as an idea. I need to go away and think about that. And I actually know the person personally that looks after our HTT, so I can absolutely do that.
That's the lady in Leeds, is it? I'm trying to remember.
Yeah, well, the chap I know is Adam Southern.
Okay. I met one of the other team at Rail Life earlier this year. Okay, well, it's just a thought. That was all. Obviously, it causes problems. You've got to slow the train down to do the UT, but you know that might still be better than trying to get a different train on the network somewhere. Okay, right. Thanks for your answers. Very, very interesting.
Right, I think we're going to pause the questions there.
Yeah, I'm just a bit concerned. We've still got another speaker.
No, absolutely.
More and more questions keep getting added. I'm thinking, poor chap sitting there waiting to get his bit in. So, okay, if everyone could just bear with us a second while the third speaker just gets into position. Have you got
is yours on questions that we didn't get answered? If we've got time at the end, I will come back to those and we'll invite all the speakers back. For the time being, we're just switching over speaker. We'll move on to the next presentation in a second.
Did you receive my email earlier?
Yeah, no,
if you send it back, do you want me to load it up for you? You can certainly do that. And that's within my technological skill. Let's give it a go. I'll just unplug this at the moment in case anyone sent me an offensive email like you've not done that thing I asked. Was it the one sent yesterday?
No.
Right, okay, let's have a look. I'm just going to make it do a bit of a manual. Just say the folder's up to date, but then it's 3:15, so it isn't, is it? Yeah. Oh, right, it's just coming. There we go. Okey-dokey. Yeah, so you've got a PDF, so you just then plug it back in, obviously.
Yeah, okay. Good. That's right. Oh, it's a PDF. Yes, that's coming. Yeah, okay.
Yeah. Good to go?
Yeah.
Yeah, how many when you are?
So my name's Dave Eveleigh. I'm the technical manager for Great Western Railway for the LTV region. So that's the 387s and the turbos that run in this area. I'm the technical manager for the depot, so the sleepers maintained at Reading as well, and things like training and occupational health and safety and environmental performance for me as well. So it's yeah, it's quite a diverse role. But before this, I was the fleet engineer for DMUs, and then I transferred over to the EMUs for when the 387s were introduced. I mentioned that because that's where I met a person called Paul Barnes, who invited me by mistake to a meeting, and if people are used to Great Western's presentations, you'll notice there's a distinct lack of a certain train in this presentation, and some of these slides are so yeah, there's no pointy trains in this presentation. Because it's so it was a common mistake. So because I was the EMU or electric train engineer, so to speak, yeah, I got invited to meetings about IETs, and so yeah, so I was invited to a. Here we go. Find the page down. Yeah, so I was invited to a meeting. Was that turned out to be about IETs, but it was a good meeting, and we struck up an ongoing relationship, and just in case. Okay, yeah, so we met regularly at Guildford House and over the road in the canteen, and it was pretty clear early on that it was more likely that we'd be successful in getting this installed on a 387 that was fully under the control of the Great Western Engineering internal engineering function, without having to negotiate some of the contractual issues. That, and bear in mind, this was sort of 5 years ago, before maybe even IETs had been delivered. So, so you know, Great Western was we weren't the first. So as I think in the previous presentation it mentioned that the East Coast had used pantograph imagery and had graduates looking at footage from Scotland down to London, literally. And there was some early footage where an algorithm was run to look at the pantograph, which is similar to what was mentioned in the previous presentation. So looking at the wire, looking at contact force, but all through image recognition rather than any physical sensors, which obviously greatly simplifies things. But it's fair to say, I think that Network Rail had trouble getting it over the line in terms of getting it installed onto a vehicle. And obviously, when I say Network Rail, it's a big organisation, so it's the people in Network Rail that I was dealing with. And so, as I've got in the bullet points there are, I think the more barriers there are between the passenger and the person who can deliver, the less likely it's going to succeed. So every other operator had externally contracted maintenance. So Siemens maintained a Siemens train, Bombardier maintained a Bombardier train, and then so not only has Network Rail got to negotiate with the operator, so the operators then got to negotiate through to the entity in charge of maintenance, and then when actually the costs and benefits for all Network Rails, why would you put a lot of energy into that when, so for all of our successes in Great Western with this system, the engine of the 387s hasn't changed because those delays were never ours in the first place. And that keeps coming up. Yeah. So I've probably skipped ahead a little bit. So the system is an image recognition. So it uses, there's no sensors. It just uses the image from a camera that's already there. Admittedly, we fitted a higher definition version, but it turned out that wasn't necessary. And then onboard processing analyzes that footage, and then we look for pantograph height, wire stagger, contact force, and if the pantograph no longer looks like a pantograph, so if it's been damaged, well, we'll come on to that. So going back to the beginning a little bit, the important part for me about this project was about the relationships that were built between Network Rail and Great Western. So bear in mind, obviously, up to this point, Great Western wasn't a particularly electrified route. So there were relationships to be built and people to talk to. And not just Network Rail, Great Western, but obviously 387s were new. So there were relationships within what was Bombardier, Great Western to be built and people to get to know each other. It was touched on earlier that the data early on, very early on, we realized that the data handling needed to be considered and that the processing had to be done on board. And at that point, the algorithms that we hadn't been optimized. They were all running in MATLAB, and so we're running at 2 or 3 times real time, which we were improved as part of the project, part of the funding, and now it's real time analysis on board. And the reason I've mentioned this is because I'm not sure how far this project would have gone if I hadn't changed jobs. So then I changed jobs to work at Reading Depot. And working at the depot, you've got quite a lot of resource available to you. So When we needed a Wi-Fi network in the yard, I had a plant team that reported to me that could install a Wi-Fi network in the yard. I had a technical team that could do in-house design scrutiny. I had technicians that could install this equipment when it suited Great Western, so it wasn't too disruptive to Great Western to get this equipment fitted, bearing in mind all the benefits, network rails and not Great Westerns. So obviously with new infrastructure, there was some and new trains, there was some teething problems. And with hindsight, it's easy to pick out all the different issues, but obviously at the time there was a lot going on. So we had a high initial wear rate, so the carbons were wearing out much quicker than anyone had anticipated. But of course, the wire was all new, so there's no patina to it. The stagger on the Great Western Main Line is too compliant, so we end up with a trough in the middle of the pantograph. And then when you have the trough, as you go into the 0 to 12 mile infrastructure, the wire goes a bit wider, and you end up with accelerated wear on the edge of the trough, because you've now got a wire trying to climb out of the trough. You end up with side forces. We have traditional impact damage from bits and pieces, and the 387 itself had problems with control issues. So there was a lot going on. There were a lot of issues, and I put binoculars there in the exclamation mark, because I was given a pair of binoculars and told, oh, you know, and I've literally got a pair of binoculars behind my desk in a drawer. And I should have taken a photo, because I don't think, well, I assume people believe me. And I was just like, there must be a better way than going out there with binoculars, looking at trains, trying to see which one was damaged, and then backtrace where that one's been, and try and work out where the damage occurred. And I was told, no, that's how it's done. So yeah, so time moved on, and then all of a sudden, out of nowhere, the conversations with Paul and were sort of still happening. We were keeping in contact, and then all of a sudden there was an opportunity for funding by Network Rail to use this image recognition technology that was sort of touched on in the other presentation. It was limited funding, so going back to the relationships thing, we had to Alstom have contractual obligations about being the design authority, so we needed to use our relationship with them to allow the local team to do that design authority without incurring costs. Like I said earlier, we used Great Western Resource to install infrastructure and the kit, and it had to be reversible because it was a very short-term trial for 4 months. And then I'll come back to it again, but but of course the benefit is all great in Network Rails, as it's seen, but this first trial was a success, and Great Western and Network Rail jointly funded the next stage. So even though it doesn't come out in any of Great Western's KPIs in terms of delays, obviously the end passenger, it was seen that benefited. So touch on the RSSB project T1010, which was a project that gave commercial models and a design for an open system, which is what you were talking about earlier. I mention this because we were really aware of this at the beginning, and this whole idea of data ownership and who owns what. We went in with we thought we went in with our eyes open, but now that the project has matured and there's a mature product at the end of it, and now it's having to battle in the real world, and so yeah, so Network Rail are, again, I'm using this term as if it's one person, but yeah, so Network Rail are, well, now that they're devolved, the different routes are taking different approaches to the same system, and so some are happy with the off-the-shelf proprietary system, and then other routes are trying to go down the path that was mentioned in the previous presentation about having an open data source. But of course, when your system provider's source of income is a monthly subscription fee to a system, they might not be too keen on you just selling you an Excel sheet full of data that you then do the value add with the front end on. So luckily I'm not a commercial person, so I've left others people to worry about that. But it is a real problem, and it's probably been the most significant issue of the whole project, actually. So yeah, so onto the system. So as was mentioned, GPS. So there's a dashboard. You can all the image processing is done on train. You can, so if something of interest happens, you can then put a request back to the vehicle, and then the vehicle will offload the footage of interest, because it's not possible and not necessary actually to transmit the images. You're not interested in the images, you're interested in the how high was it, what was the contact force, and the parameters. So we can actually rebuild an animation from the data rather than having the video footage. So you can see a simulated pantograph and a simulated infrastructure playing back a wireframe rather than the high data rates of having HD video. You can have the video if you need it, and it was an important decision early on, because I think these systems have come before, and it only takes a handful of false activations for people to lose confidence in the system. And so by having the video, you can prove that there is an issue without sending people out to the site and then either determine there wasn't an issue or not. And so it's important for confidence to have access to that real video as well as this simulation of what's going on. So yeah, so you can see that footage. You can get alerts for things that are out of parameters, and yeah. So it was touched on earlier about video positioning. So we did the same thing. So what we found was, coming out of Paddington, there's multiple routes. So knowing GPS, knowing you're coming out of Paddington is helpful, but knowing what particular route it was, if you've just had an alert saying there's been a high impact event, I need to know where that was, and you want to know that within 10 seconds. You want to know, as you want to present to the signaller, this is the issue, this is the location. So GPS on its own wouldn't do that. If you think about the possible combinations of routes out of Paddington, so that led us down the image recognition route for location. And you might think, why is there a slide here with two pictures of the same thing? And it's because the one on the left is the video as would have been seen on the train, and the one on the right is the frame, the reference video, and the match, and so you can see how close they are. And this, so although this is very useful, so people asked about tunnels earlier, this is very useful for tunnels where you haven't got GPS. It turns out you don't need this level of complexity if you combine the other open source information that's available from Network Rail. So you can get the, I can't remember the name of it, but you can get access to the routing information from Network Rail. And this image recognition technology was actually originally developed for connected DAS. So for a driver advisory system, you need to know which route you're actually on for the same reason. So the system does monitor the infrastructure, but it can monitor the train as well. So pantographs can become damaged, and they can run for a surprisingly long time in a damaged state as long as they're maintaining contact with the OLE. And we've had trains run pretty much the length of the electrified Great Western Main Line with it damaged, and because the Great Western Main Line is such a constant wire height, really, it's only when the wire height changes that you find out, and then you find out the hard way. So we haven't done too much with this, but the point is that it's a image recognition. So there's nothing physically interacting with the pantograph, but you can detect whether it's healthy or not. And it doesn't have to be as big a damage as this. It could be minor damage. It could be plastic bags wrapped around the pantograph. So pretty much the first run out of Paddington, we had our first success. And so on the left is the still of the footage, and then the round circle is the wire that's out of gauge on the stagger. And then the top graph is, so you got the two lines, that's the stagger tolerance. And you can see that it's detected that the wire's got outside of that tolerance. But also on the bottom graph, that's contact force. And so remember, this is all from the image. There's no actual sensor there measuring contact force, but you can see a spike in contact force that aligns with the wire, with this non-compliant wire. So that was, like I said, that was really early find, that was, and nobody had, that was an unknown defect. So I thought I'd list a couple of other sort of successes. So in the tunnel, we identified a defective insulator. And going back to my point about the video, the reason the video was important in this case is because people were sent out to site. They declared no fault found, and then to my opposite numbers in Network Rail forwarded the video and said, no, come on, there is something. And so it was on the second visit that the defect was found. So that green line is gradient, and so a non-compliant gradient where an overlap wire that's non-compliant, and so by having a non-compliant gradient, you end up with non-compliant contact force. So that was another success. And then recently, so I think I pinched that photo on offline, but this year, Great Westerns 387s have gone lots of places that probably a year ago wouldn't expect it. I mean, so they've gone to Heathrow, they now go to Cardiff, and this system was it was used to support the risk assessments to get the trains there. So by having compliant infrastructure, it's not quite so onerous. But but for example, tunnels were mentioned, so there is problems at the moment with contact, maintaining contact with the conductor bar in the Severn tunnel. And this system allowed us, through the driver training runs, to adjust the driving technique to take power in certain places, to effectively put a notch restriction in, power notch restriction to limit the arcing at the interface. And the reason we were able to do that is because the information was so easily available. Whereas if we'd had the old system, it would have been still pulling hard drives and just all the time delay and the faff in that just means you just don't use the information that is available. This system was also used, so we had a traditionally instrumented pantograph to support the Steventon bridge speed increases, and we used the alert vehicle in the same formation so that we had reference data. So you've got this instrumented 387, and then immediately behind it you've got the alert system, and so we were able to compare recognise data from the instrumented pantograph against this system. So, and like I said, it supports the risk assessment for changes and changes to scope. And those instrumented pantographs are not easy to fit as one-off events. You know, and if they're available, you know, these things are in demand. So a live project is that Great Western 387 is fitted with insulated pantograph horns to reduce the envelope of the electrified components on the vehicle, and so it makes things like bridge clearances and the like easier for the future. The point being is that this system has opened the doors. So this would have probably happened anyway. We would have worked up a risk assessment to fit an insulated pantograph horn, but this system's made it so much easier because you can just send it out, you can monitor it. So your management time is better spent on other things, really. So this is a bit of a busy slide, but it's to show that we're now gone, well, the Western route has now gone back to MATLAB. And so the raw data from OLERT is now being combined with the other data that Network Rail has. So there's that top. So there you've got stanchion information there on the top, and infrastructure information. You've got track speed and CAN information. So the OLERT information is now being combined as was talked about in the previous slides. Like I say, this is the relevant bit here when I was talking about the RSSB project at T1010 is that for the supplier, you know, the value add, and they spent a lot of time based on our input to them developing an interface, and then when it actually came to the hard world of the route paying for it, they said, "Oh, we don't want your interface. We just want the raw data, and then we'll create our own interface." So this slide, I haven't edited it. Hopefully there's nothing too controversial in there, because it's the commercial team's observations on what I've just been talking about. The idea, the preference between CapEx, just pay for something, it's mine, don't have to be held to ransom for ongoing OpEx costs. So the challenges from the Network Rail commercial team are on the left, and then what their view as victories or changes are on the right, about agreements to access to information, and developing Network Rail's own internal data handling capabilities. So I think, yeah, so I've tried to sort of summarize some points here. Some are technical, some aren't. So originally we thought we need stereo images to do this, but you don't, because the vehicle's moving, you can create a stereo image from that. We used keeping the camera clean was a real challenge, and so we used a ceramic coating that fills the imperfections in the glass. Talked about GPS and the use for the Network Rail open source information as well as image recognition. The fact that vehicle modifications, especially on a vehicle like a 387, are eye-wateringly expensive. And so if you wanted to get information into the cab, actually all drivers got tablets now. So this system, you can get the information to the driver in the cab without having to make a modification to the train. I mention that because obviously that's transferable for other things, you know. So if all drivers are going to have a tablet in the future, then other colleagues, then that's a lot cheaper than doing it through a physical change to the vehicle. And just a pretty obvious thing that vehicle image recognition is non-intrusive. So that's when you're dealing with 25,000 volts, that makes safety arguments a lot easier. Some other thoughts. So, talked earlier about the perception that this is all Network Rail's benefit, but actually we've got 387s to Cardiff so much easier than we would have done otherwise. So are the benefits all Network Rail's? The interface thing and the relationship with our RSSB project T1010, and I don't know if anyone else has had any success using. So there are framework agreements in that RSSB project, but it didn't seem to survive contact with the real world. So. So I think you mentioned about prescriptive science standards as well. So we've gathered all this information you've never had before, but you can't use it because the standard says you've got to do this. So, so we did have, people will know, I guess, Andy Bowditch, and he was seconded into Network Rail to try and work out how to take advantage of this, not only from a asset management point of view, but from an instant response point of view. So if you've got a standard that says every train has got to be cautioned after a certain event, but actually do you if you've got high definition video available? But if the standard absolutely says no, every train's got to be cautioned through, which, so yeah, it's just, so just a bit of a question there. I think there's something here about the fact it's an interface, is that it's an interface between different companies and an interface between obviously different systems, but it's so yeah. So I mean, we gather data on things internally, but it hasn't had quite the impact that this project has. And I just wondered about that, and I think it's because it's this interface. It's looking at different companies looking at each other rather than Great Western. Just I mean, we've got asset management monitoring in other areas, but it hasn't quite got as much interest as this has. I think that's just the difference. It's the fact it's an interface between companies. It's a bit twee, but it's true. The relationships that we've built are paying dividends. We talk to each other regularly about OLE issues. People in my team now don't speak to me, they just email Daryl in the middle there directly if there are issues with the OLE. So I do think it's important that the relationships that are built, Alstom, that aren't shown, opened a lot of doors and made this project deliverable. And then, so people can read this later, they're just the perceptions of what this system does for the different groups. And then really the point is that it is only a camera on a roof connected to a PC. So literally, it really would not take much to install this system on an X319 as it was to install it on a 387. It's, especially if it's a steel body shell, it's quite easy to cut a hole in the roof and stick a camera on the top. Yeah, so that's it.
Thank you. Right, any questions in the room, first of all? Right. I have no questions online, I'm afraid.
It was a comprehensive.
If anyone is online who was mulling a question, please either unmute yourself and speak now or write something into the text. If not, we'll bring all three speakers back and do a few questions. We have a few questions from the two of you as well that we didn't get answered, but I'm hoping someone will come up with a question for themselves there first.
Not too hard.
That's a no. I'm going to leave. Sorry.
Okay. There we go. Right, one question. So Rebecca Stelick has asked, how do you get contact force from looking at it?
It's acceleration, so you can, because you know the mass. And I'm saying this as if I can do it. I can't do it, but you can do it through. It's basically acceleration. So you know the mass. You know, well, yeah, you know the mass. You know how quickly it's moving. You know force.
Fair enough. Anybody else? If not, can we bring all three of you to the front and then we can go through any further questions?
Do our standards let you, which I'm intrigued by, do our standards let you use that as a calculation? Is that accepted?
Well, and that was why we ran the in formation with a fully instrumented 387 to get that. But yeah, and it comes up with the right answers. So the contact force is what the vehicle is set up to. So unless someone's tweaking the results, the contact force should be 90 newtons, and the system regularly reports 90 newtons as the contact force. So
so one more comment for your presentation from Simon Wadsworth again. This is thanks for an excellent presentation. Explains how you locate a train in the 7th tunnel without GPS. Now, if we can just get the 307s to Temple Meads and Bath. Just to comment there. Right, that's all the questions I have for you. I'm going to go back to a couple of questions for your two, if you don't mind.
I need to make sure Brian's on video.
It says interesting details about the equipment fitted to an EMR 360. What are the timescales for fitting the whole fleet, and are there any other Angel EMU fleets that this sort of equipment is maybe fitted to?
Well, that's definitely a Brian question.
Yeah.
Yes, there we go. Well, that's the answer to the second one. Yes. The answer to the first one on the 360s, we're in heated dialogue, shall we say, of getting that sorted. And I've been embarrassed before by saying things in public, but this year, that'll do.
Gives you quite a lot of
I made the stupid mistake before about saying something in October this year, but no, yeah, definitely this year.
Okay, thank you. Next from Joshua Hatton. Is there a desire to log Eveleigh voltage for harmful transients, etc., using high resolution sampling on Unit 2? It could give useful resilience information.
Interesting. Certainly on our Pandas system, no, we're not in contact. As was mentioned before, having contact with a 25,000 volt system when monitoring it is fraught with difficulty. So our accelerometer, transmission dynamics design, doesn't have any direct contact as in electrical contact. It's wirelessly transmitted off. But yeah, something we could consider. Think about it.
Okay. Wheel load impact detection or WILD combined with this is from Neil Halliday, by the way. Wheel load impact detection or WILD combined with RFID tags on vehicles allows detection of unevenly loaded weapons. It's just I'm not sure if that's a comment or a question.
Sounds like a great statement.
Yeah, no, it's absolutely true.
I'm going to say earlier when the question was up, the Great Western Line does have rail band, which uses acoustic monitoring to detect bearing flaws, and you can tell by the speed of the floor that the acoustic sound which part of the bearing it is, because the bearings rotate at different speeds, different races, and we've had.
They're only just being picked up though.
Yeah, so we've had a lot of successes with that. There's rail band and acoustic monitoring of bearings, and like I say, you can detect where in the bearing the floor is through the frequency of effectively the clicking sound actually. That's handwell.
Right. Thanks. Just got 10 minutes. I think that's all the questions I have online. Any more questions in the room from anybody? No, I think in which case,
Okay.
Well, ask questions. I'll hand over to you.
It looks like it's back to me at this stage. So, Jason, Brian, David, thank you very much. I would like to apologise to the people about the sound at the beginning. I'm going to blame Road 2 because they say they give me 5G signal, but obviously a crap signal. So, unfortunately, the way things are, we can't run the camera off a Network Rail computer because you can't plug it into the computer. So we have to use a personal computer, and we can't get onto the Wi-Fi in Network Rail's offices. So we have to use a mobile signal, and hence there's a problem with connection and sound. So I do my best. It's an ongoing learning process to try and actually film with live people and transmit it. It's difficult because we can't practice until we've got all the people on there. So it's one of those things that will evolve, we will get better. Apologies for the failures at the beginning. Hopefully we got it sorted out, and let's hope in the future for the next meetings, it will actually work a little bit better. At this stage, I would like to ask James to do the vote of thanks for our 3 speakers. Yeah, come show your face on the screen.
Oh dear, I'm not sure about that, but I was hoping to get onto the microphone, so hopefully people can hear me. I would just like to say thank you very, very much to Brian, Jason and David. I have to say, when we were talking about this as a topic, I hadn't realised quite how absolutely absorbing it's been. And I'd like to say thank you very, very much. They really has been a demonstration of how the railway industry can work together and is working together. No matter what the politicians might think, the railway industry is working together. And there are just so many wins. This is ticking all the boxes. I was trying to think of something where this doesn't benefit. And it's actually safety. It's removing men from dangerous areas, or boots on ballast, which is actually a phrase I hadn't heard before, but I quite like that one, and undoubtedly I will have invented that tomorrow. That's you know, safety is a big thing. It's the innovation, and I have to say it was nice to hear that prescriptive standards are starting to be challenged, or actually probably more specifications masquerading as standards are starting to be challenged. That's nice, and it's good that as this meeting, the interest that was shown in the railhead treatment is possibly something that that tonight's meeting may have actually changed a little bit in the way that this project is developing, perhaps even. So yeah, it just goes to show the benefit of institutions getting together, the PWI and the IMEC coming together, and again working together. It demonstrates the benefit. And one last thing, I was going to say, and thank you very much to David for actually demonstrating or showing how the local team getting together and doing something actually just demonstrates quite how powerful this all is. And I guess just on a very, very personal note, the one thing I've learnt more than anything, and I think I've sort of come to realise that infrastructure inspection is actually both monitoring and measurement. And I hadn't actually thought of that before, but that's been a bit of a eureka moment for me personally. But I would just like to say, and thank you very, very much to the 3 speakers. I would say we demonstrate our appreciation in a normal manner, but sort of virtually, we can